This is an AS Maths question using trigonometry for triangles. In a triangle ABC, side AB has length 10 centimeters, side AC has length 5 centimeters, and angle BAC is equal to theta, where theta is measured in degrees. The area of the triangle ABC is 15 centimeters squared. What we need to do in part A is to find two possible values of cos theta. So it's always useful to draw some sort of sketch so we get a rough idea of what this looks like. But beware, this is not to scale. So not to scale. So don't look at my diagram and think to yourself, it's a right angled triangle or it's an isosceles triangle. This is so that I can just get an idea of where the sides and angles are in relation to each other. So we will label this A, B and C and we'll mark in the information that's given. I've been told that AB is 10 centimeters, so we'll mark that in. AC is 5 centimeters and the angle theta is the angle BAC. So that means that theta is here. So I can see that I've got two sides with the angle between them. I also have the area of this triangle, which I've been told is 15 centimeters squared. Whenever I've got two sides and an angle between them, I can use the area by doing half AB sine C, where A and B are two sides of the triangle, any two sides, but angle C is the angle that is between sides A and B. So my A is going to be 5 or 10 and B is going to be either 5 or 10. It doesn't matter which way around. So I'm going to put area, which is equal to 15, is equal to half A, I'll call that 5, times B, I'll call that 10, times by the sine of C, which is theta. So I can rearrange this or work it out. So I've got 15 is equal to half times 5 times 10, that's 25. 25 sine theta. So I'll have sine theta is equal to 15 over 25, and I can divide both sides of those, divide the top and the bottom by 5 to leave me with 3/5. Now I don't need to find out what theta is going to be. I can use sine theta to find cos theta, and the way I'm going to do that is to use the identity sine squared theta plus cos squared theta is equivalent to 1. So that should be fairly straightforward. Sine squared theta, so that's going to be 3/5 squared plus cos squared theta is 1. So cos squared theta is going to equal 1 minus 3/5 squared, all squared, which is basically 9 over 25. And if I do that, I'll get cos squared theta is equal to 16 over 25. And I want cos theta, so I'm going to square it or square root it. So cos theta is equal to plus or minus the square root of 16 over 25. So I can see from that I've got some nice numbers here to square root. Cos theta is equal to plus or minus root 16 over 25, which is 4/5. So these are my two possible values for cos theta: positive 4/5 or negative 4/5. Let's move on to part B. Given that BC is the longest side of the triangle, we want to find the exact length of BC. Now if BC is the longest side of the triangle, and the longest side of the triangle is always opposite the largest angle, so if I look here at my diagram, there's BC, longest side, this is the largest angle. Again, don't look at the diagram, it's not to scale. If this is the largest angle in a triangle is always an angle which is obtuse. You cannot get three acute angles in a triangle if you have a longest side. Right, so I know straight away, let's write down that theta is obtuse. Don't need to write this down really, since it is opposite the longest side. This is optional here. This is just to help you see what's going on. The longest side, BC. Now, since I have two sides and the angle between them, and I want to find the length of this side here, that means I'm going to be using the cosine rule. And so I'll have a squared is equal to b squared plus c squared minus 2bc cos a. Now let's think about which side is which, right? So A, that's going to be BC. That's the side that I'm trying to find. B and C, that can be the 5 and the 10. So 5 here, 10 here for B and C. Now for cos A, I have two possible values, the plus 4/5 and the minus 4/5. I guess one of these is going to give me an acute angle, one is going to give me an obtuse angle, and I want to pick the one which is obtuse. Or I can just look at this equation and say, well, what's going to give me the biggest value for a squared? Putting in a positive 4/5 here or a negative 4/5. Well, if I put in a positive 4/5 here, I'm going to be subtracting a value. Yeah, this is going to be subtracting something from b squared plus c squared. But if I put a negative 4/5 in here for cos A, then the whole of this part here becomes negative. I will be adding something to b squared plus c squared. It's going to give me a larger value for a squared. So I'm going to be using the negative 4/5, because negative 4/5 here, this whole part of the expression here will become negative, subtract a negative becomes adding. So that tells me all the values I need to use. So a squared is going to equal to 5 squared plus 10 squared minus 2 times 5 times 10 times by negative 4/5. And you'll see that that will end up getting that added on. So a squared, that's going to be 25 plus 100. Now, because of the negative here, I'm also going to be adding a value of 18. So I will have a squared is equal to 25 plus 100 plus 80, and that gives me 205. So the exact value of a is going to be the square root of 205. I guess I could leave it like that. It doesn't say anything about a surd or anything like that. It does say exact value. Actually, that doesn't simplify any further, so there isn't an or something. But what we don't do is change it to a decimal, because it asks for the exact value here. So square root of 205 centimeters would be my exact length.